Welcome, everyone. So good to see you here. I'm just going to give it another 30 seconds maybe to let more people join in. So good to have you here with us today. My name is Helena Barmer. I am helping out to host and moderate this event today together with Andrew Trask and Matt Leonard. So super welcome to our webinar doing data science on remote data. And I see that you're joining in, but we're just going to go really quick. And just for some housekeeping, if you have any questions during the webinar, just ask them in the Q&A box. So you have the Zoom chat, you have the Q&A box. For general questions, just ask me in the Zoom chat. I will be there to help you and guide you. And any question to Andrew and Matt, just use the Q&A. So, and if you're confused, just ask again. That's why I'm here, actually. So I want to introduce our speakers today. It's Matt Leonard, who is a machine learning engineer and educator, previously a content developer and product lead for Udacity's School of AI, and most recently an AI engineer at Augustus Intelligence. And then we have Andrew Trask, who is a PhD student at the University of Oxford, studying privacy and deep learning. So that's really targeted for today, right? Also an author and have a really cool blog and started the OpenMined community. And also I want to say it was his birthday yesterday, so you should just send him a belated birthday gift in the chat. Please go ahead. So Matt, Andrew, if you're ready, you can go ahead.
Let's do it.
Sure.
All right, so I'm going to share my screen, and then when I do, I'm going to explain sort of the setup that we have here. So on the left, you're seeing a screen share from Matt Leonard's machine in, where are you, Matt? I know you're in California. Where?
You're in San Francisco. Yeah.
San Francisco, California. And then on the right, you have my machine here in the United Kingdom, in Oxford. So I don't know, we're roughly 8,000 miles away from each other, 9,000 miles away from each other, something like this. And what we're going to walk through today is an example for how, I, as like a data scientist here in Oxford, can like study some data that Matt has in San Francisco, California, where I'm sure it's warm and sunny and beautiful and not cold and dark. And yeah. So Matt, you ready to do this?
Very ready. All right.
Please, please do pop questions in the chat as we go. Of course, I think Helena will interrupt us and also help facilitate answering questions at the end. So we'll do a little bit of experimentation here. Everything that you see in this demo is with SIFT 0.3.0. So just to give evidence to that, I'll import SIFT, and you can always check the version of SIFT which is in here. Very shortly, SIFT 0.4.0 will be coming out, which will be adding some new library support for additional libraries that you can do remote execution with beyond the initial one with PyTorch, which is very exciting. Cool. So just to start out, Matt, would you be so kind as to launch a Duet server in your notebook in beautiful San Francisco, California?
Absolutely. Here we go.
So when Matt executes a cell, it reaches out to a node that OpenMined hosts on the public internet that is going to make an introduction between Matt's notebook and my notebook. So Matt has gotten this little code, not unlike a Zoom link or a Google Hangouts link. And what we're going to show is you can actually do sort of data science coordinated like this over a Zoom call. So Matt has just sent this code to me, which is great. So I'm going to copy this little code here and note that we're both connecting to the same network URL. So there is a default one that we'll try to connect to for SIFT, but there's actually a collection of different nodes that we host. This is one of them. You're free to use it, and we'll make these URLs. If you don't put one in, it will use the default one. Right now, the default one's been a little bit slow lately, so we're going to look into that after the demo. But we have sort of double, triple backup. I think we're running 3 different nodes at the moment. So here's what's going to happen. So he sent me this code. I'm going to run the same command with this code populated in here. So I guess actually I'll hit return so you can see the full command. And it gives me a code to give back to Matt, right? So I'm gonna go back over here and drop this code into the chat Hangout, which is great. And then Matt will pop that into his Duet partner client ID. And then when we do this, what happens behind the scenes is metadata gets sent about our network connection to the external node, just like any other peer-to-peer technology, and we get a direct connection. And as you can see, it's been connected between our two notebooks. So basically, in Matt's laptop in California, he's got a server running in the background inside of this Jupyter notebook, right? And then here in England, I've got a pointer to that server, which is this sort of Duet variable. So let's just maybe Matt, you want to explain this kind of Duet live status bit going on down here?
Yeah, so basically the objects are like tensors and other data that exist on my computer, and requests are requests from our data scientist, Andrew, who potentially would want to get data from us. And then messages are communications between his machine and my machine. So when he's trying to perform operations on data on my computer, then he'll be sending messages along. And so this is basically just keeping track of all the different things that are happening between us.
Brilliant. So let's watch those change. So I've got this tensor called x, right? And now I'm gonna go x pointer equals x dot send to Duet, right? Which is send it to the Duet server running on Matt's machine. And so when I execute this, you should see objects and messages increment. I think objects should increment 1 and messages will by 1 or more than 1. Exactly 1. There you go. So I just sent this tensor over into Matt's machine. And what returns to me is this x pointer object, which for those of you familiar with SIFT, will know that it has lots of torch functionality. And if I go y equals x pointer plus x pointer, you'll see that the number of objects increments again. And if I look at y is still a pointer to the result. And I can do y.get, and it will ask to download this result from Matt. Now you'll notice that I was able to download this without Matt being able to really intervene. So this object, sort of knew that it was only constructed with information that came originally from me, right? So it sort of the system knew that there was no sort of private information or Matt's information that could have been used to create Y, because it was only used by only created using variables that I sent. So Matt, do you want to load in like a little example data sets? Because basically that's not quite as interesting because it's just sort of remote execution, coordinating remote machines. It's cool, but that's not what we're here to do. What we actually want to do is show Matt bringing in some data into his notebook in San Francisco, and then me being able to work with that data despite the fact that I'm here in England. So you want to explain those queries, Matt?
Yeah, so here I'm creating a torch tensor. So this is, PyTorch. So I imported PyTorch up here. And so I'm just creating a PyTorch tensor like you would normally. And here I'm just giving it a name. So this tag data, I'm sending this. So data.send. So I created a data pointer on my side. It's searchable, so Andrew can find it. And yeah, this is the target. So basically this is my data. These are the labels, the targets, tag this, send this as well. And we could see what we create. So we see here, the data pointer and the target pointer are these tensor pointers. So pointers to tensors.
Brilliant, but those pointers and the data are still on Matt's machine. However, since he marked the send method with a sort of searchable equals true, that means that I can have view permissions to actually see that these tensors are existing as me. So I can't even by default see all tensors that are on Matt's machine. I can only see the ones that he explicitly allows. So I'm going to go duet.store, which is the object store, which allows me to see what's searchable, but that's not very easy to read. So we have this like nice pretty print that'll turn into a pandas table. And now I can see that there are two objects in Matt's store that have been labeled with data and target, right? Which these are the two data and target variables that he added. And if I want to manipulate these and so that I have pointers to that information, I can do that one of a few ways. So I can go duet.store 0. So I've got like 0 and 1 index here, right? So 0 and 1. And that will return to me the data pointer. I can also go duet.store and pass in a string and pass in one of these tags, and that will also return the same variable. So I can go data equals duet.store data. And additionally, one other thing I can do is I can go duet.update vars and pass in a globals. This is like a little bit of a convenience function. Maybe this is too much too fast, but if I run this, what it does is it populates variables in my own machine according to all the tags that are here. So behind the scenes, it created a data object and it created a target object. And you'll notice I had never created a target object sort of manually. So this is like the one that I like to use because, you know, Matt can load in a bunch of variables on his side and name them all. And then sort of instantly I'll get a bunch of variables that have the same copy. And if like Matt changes his variables, and I just want to update it, I can just run update vares, and then sort of I'll get sort of a picture, you know, or sort of all the pointers to a lot of the variables that Matt loaded into his side. So now, before we do anything, Matt, I'm going to try to steal your data. Are you scared?
Terrified.
Terrified. All right. Lots of confidence in this tool today. So if I do data.get, which was the same .get up here, to try to download Matt's private data set, what's going to happen? Oh, authorization exception. You do not have permission to call .get on the object with this ID. Please submit a request, right? Now, what does it mean by a request? Now, a request basically says, hey, I'm going to name this request, data access request, right? And I'm going to say reason because I want to steal your data, right? And I'm going to submit this request by just running this because I'm asking for this variable. And you'll see on this left side here on Matt's machine, all of a sudden, oh, blink, 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 I've got a request in my request queue. Matt, what do you think about that request? I'm trying to steal your data. Are you going to let me do that?
Well, first, I'm going to check out my request. Pandas. Yeah, reason, because I want to steal your data. I would not like to allow this.
Oh, man.
Yeah, I'm sorry. Maybe next time.
All right, well, how about you deny my request just so it clears out from the queue?
Request 0, deny.
There you go.
Again, and it's gone.
All right, and so now I go data.get. Oh, still get an authorization exception. Bummer. Okay, cool. So basic permission seems to be working. Let's do some basic data science. How about I just and we're gonna do something really simple, but we'll start really simple. Let's say I do data.means. I'm just gonna get the average of data set, right? So it's like a basic torch mean. And now I'm gonna go average of data set. I think I didn't spell that right. Average. Average. Okay, yeah, now we're good. And I, of course, cannot call .get on this because it was a variable that was generated in part from private data. So now I'm going to request this, and I'm going to say request name dataset mean. And I'm going to go reason is I would like to know the average value within this dataset, right? So now I'm going to submit this request. And Matt, what do you think? Looks like you've got a request.
See. Okay, I would like to know average value. I'm okay with that. So I'm going to accept it.
Brilliant. So now I'm going to go to average of data set and say .get. Da-da-da-da. Now I know my data set has an average value of 0.5. And maybe this is interesting for normalization or sort of me learning high-level statistics of my data before I do something else. But that's pretty simple stuff. You know, PyTorch obviously has a variety of things we can do. What about more sophisticated, machine learning-y stuff? How about we train a model on this sort of, toyish data set? So I'm gonna move down a little bit. I've got an example neural network here. It's just like a simple linear neural network in PyTorch. We do import from the SIFT module subclass as opposed to from inin.module in Torch. So we're going to create this model. So model equals net. And then for TorchRef, there's this interesting thing where basically if I created this using, I'm passing in the reference to Torch. There's multiple different, actually, yeah, I'm going a little too fast. So let's say I wanted to just initialize a bunch of variables on Matt's side. So on this Duet thing, this Duet handle that I used to send information, I also have a reference to Torch. This reference to Torch, it prints the full API when you do that. But what this reference to Torch actually is remote Torch, meaning if I call remote Torch dot zeros, Oh, we don't have all the API in it apparently. Let me see. What would be like a good mode? Give me a sec. Got in here. So this is what you're looking at here is basically the allow list. So the way that Syft works is that it allows you to remotely execute a sort of a Python library, right? So in this case, we've added a bunch of PyTorch methods and classes and this kind of thing to an allow list. And I'm allowed to execute any of these methods that are in this list, but not necessarily every method in the PyTorch API, because some of them can access the file system and all this kind of thing. And we're adding them individually and sort of checking each one to make sure that it's secure. So when I look in here, I can see a variety of different things. I'll go down to one that I know is in here that we did earlier, which is an optimizer and a criterion, right? So in this particular example, what you're going to see me do is I'm going to go duet.torch, and then we have the optim package and a stochastic gradient descent module. Now that stochastic gradient descent module, like we'll do this loss variable first, right? When I implement this, it does not create a loss variable locally. It actually creates it on Matt's machine, right? And that's a big deal because it means that I get the ability to like sort of call the module API, not just send objects and manipulate objects sort of remotely. Okay, so now let's go back to our example. We should, I believe zeros is added in the next version of Torch, but in the one that's on PyPy, it had not been added yet. So we're going to create a model. And when I go create this model, I can choose whether I want to create this module locally using my local PyTorch, th, or whether I wanted to do it doing duet.torch. In this case, I want to do my local one. So I'm going to create my model. And then I'm going to call .send. So I'm getting some reference code from down here, which is great. I think we want this to be a little bigger. So model equals model.send. So now it just sent the model down to Matt's machine, right? And I've already created my criterion on Matt's machine. And now I'm going to create my optimizer, right? And again, this is using Matt's torch to execute this. And it's passing in model.parameters, which is a pointer to the list, right? The model.parameters calls, again, on Matt's machine. So it's all remote PyTorch. And then a little training script, right? And if and there you go. Now it's training, right? And the essence of this script is that each line that's executing is not executing on my local machine. It's executing on Matt's machine over this peer-to-peer connection, right? And let's look at the results. So let's say, okay, maybe we want to see how accurate our model was. So I'll go loss.get. Oh no, authorization exception again. Why is there an authorization exception? Because part of the computation graph that was used to create the loss variable involved data in target, which came from Matt's machine, right? So loss might have some private data in it, which means I first need to request it. So I'm going to do another request. Name equals loss. And reason equals I want to know the performance of my, or the accuracy of my model. Right, so I'm going to submit this request. Matt, you have another request.
All right. Request. There we go. I want to know the accuracy of my model. I will go ahead and accept this. Yeah.
So generous. Okay, loss.get. Now we see that. Now scroll down a little bit, Matt. Something really important happened here on the left. So when I call .get, the interesting thing here is that there was a warning trigger, not an error, but a warning trigger. There was a normal PyTorch warning, right? And this has to do, it's just something from some stuff being called in the serializer or whatever. But the interesting thing here is that errors and warnings, which might contain some kind of private information, like the knowledge they were done, do not get conveyed to me, the data scientist, automatically. They get revealed to Matt, and Matt gets to choose whether he wants to share that information with me so that we can facilitate data science together. And this facilitates the really important question of like how do we make it so that all the standard errors and this kind of stuff in a package that was built generically, was not necessarily built to be operated in a secure environment, don't accidentally leak information. So there's a certain assumption of execution for a lot of operations on the data scientist side because we don't want to actually leak information through any potential errors or stack traces, something like that, that could be leaked to my side. So in this case, it's an innocuous warning, but it's really important to recognize that like these kinds of warnings and errors actually get displayed on the data owner side, but not necessarily on the data scientist side. Now, secondarily, the other thing that's interesting here is that this seems kind of cumbersome. Like if I wanted to print like a loss chart or like see how my loss was changing over time, as opposed to, just like a one-off like this is like kind of manual, right? Imagine if every 10 minutes, Matt had to ask a request, accept a request or whatever, just for us to see whether the model is training. It would be a lot nicer if Matt could pre-approve a certain set of operations, under the assumption that we're sort of screen sharing, he can see the kind of analysis that I'm doing, and it is generally comfortable with what we're up to. So Matt, would you go ahead and load in what a handler?
Duet.requests, add handler. Right.
So let's make the handler for a request name called loss, lowercase. Brilliant.
To accept all of your requests.
Excellent. And then there's one other important variable that goes into add handlers, which basically refers to the maximum number of numbers that it's going to allow grand total. So this time, let's do 9, right? And what this element quota basically says is I'm going to pre-approve up to 9 scalar values, meaning a tensor with 9 values in it, or 9 tensors with 1 value in it, or whatever, if those requests are named loss, right? And so this sort of just like, this allows for some level of automation and convenience on Matt's side, while also sort of limiting his upside exposure or downside exposure, and the potential that I tried to do something, funny, right? So now in here, I'm going to go loss dot get, or something do print loss dot get, but when I do get, I'm going to say block request. It's like request block. Hold on, I'm actually. Yeah, request block equals true. And what this means is that I'm going to ask for do a normal GET request, but instead of giving me an error, like an authorization acceptance, it's actually going to hang until Matt accepts the request, right? And in this case, since he's installed a handler, this should happen more or less automatically. I need to make the name equals true, or name equals loss, but it's compatible. You said loss, lowercase. All right, and here we go. So I'm going to ask for it 10 times. So it should come through in print 9 times. And then the last one, it should actually say, no, you are not allowed to see that, right? Because that was too many numbers, right? So here we go. First ones are coming through. Good for us. Looks like our model is, training as it should. And note that a lot of the speed on this has to do with some artificial sort of timeouts and delays on the request process. I think it's like a half second or something like this that it automatically rate limits that. And so as you can see, for the first 9 numbers, which were under our quota, we got to see the trend, the actual values coming through, and the last one it was denied, and so it simply returned a none. So I think that kind of concludes sort of the main portion of this demo. The ability to use sort of PyTorch in a remote environment, in a peer-to-peer environment. Matt can load in private sensitive data from his own organization, or from that he collected himself, or maybe is about himself, or whatever. And I, as a data scientist halfway around the world, can do certain levels of experimentation, while Matt is able to maintain control over exactly what I'm allowed to download and what I'm allowed to see. And so I'm allowed to learn enough to be able to train interesting models and see loss measures and stuff like that with a certain degree of convenience. But I'm not able to download the data outright. And all these kinds of things. So I don't know, Matt, anything you want to share before we open it up to Q&A?
Yeah, I mean, I think this is like, I love Duet. It's amazing to me that, me as a data owner, I can have private data about myself, about a lot of people, and then a data scientist like Andrew can build models, can calculate statistics and all these things without ever actually seeing any of my data, which is astounding and is really going to change data science going forward. So I am very excited to be a part of this. Yeah.
Woo. Awesome. So, Helena, I have my screen shared, so I haven't been checking the questions. Maybe I can.
I have keeping track of them. Would you like to read them, or would you like me to?
How about you maybe find whichever one would be
Yeah,
best.
I found the coolest ones for you.
The coolest one.
The coolest
The
ones.
coolest
Most
question.
awesome ones.
No offense anyone who's not
So
selected.
we have a question. Does this work with any other libraries aside from Torch, NumPy, or Pandas, or anything like it?
So we have a very ambitious roadmap to add all the standard data science packages as soon as possible. So 0.4 was supposed to release a couple days ago, but we wanted to add a couple additional libraries before we released it. So it's actually being held for a few additional libraries. I want to say, I don't remember the exact list. I don't want to rattle it off, but the intention, so it does not yet support those libraries, but we are in the process of adding, NumPy, scikit-learn, pandas, like all the standard data science libraries to this framework as soon as possible. So think, in the next 4 to 8 weeks, these will be added continuously. So, and if you want to use the latest version, you can go on GitHub, on PySyft's GitHub, and you'll see that there's a branch called 0.4, which already has experimental support for some additional libraries.
And in the link I shared, you will have the link to the GitHub repo. So just go ahead and check it out from there. So the next question is Duet only limited to one-to-one collaborations between data owner and data scientists, or can it be used for collaboration between multiple parties?
Great question. So whereas Matt cannot necessarily run, so Matt can run multiple servers, but that's not really that interesting. He could run another server on another notebook or something like that. But I, as the data owner or the data scientist, I could connect to as many Duet clients at the same time as I wanted to. So like I could, open up another Duet here. Like if Matt had another server running, I could plop in this and then do, federated learning amongst, a half dozen or a dozen people or something like this. It does get unwieldy in terms of like how many people you can fit on a Zoom call to like do data science together. But in principle, there's no strict limit to the number of people that you could do a Duet interface with. Great question.
Yes. And another one is, can Matt see the actual operations such as mean you intend to do on the data, or does he only rely on your name reason message?
Yeah, so in this version, we kind of assume that the data scientist, data owner will be screen sharing, at the very least, the data scientist side, so they can kind of see what's going on and check things. In the future, we're working on 2 more sophisticated groups of features that are going to add some more sort of rigor to this. One is some way to sort of display the lineage of a data point that someone is trying to download, meaning, which of my private variables did it come from? What operations were used, what methods were called in the process of creating this variable, so you can get like a sense of what it, which variable people are trying to download. And the second one, which is I think even more exciting, is automatic differential privacy budgeting, meaning that, so Matt, instead of adding a handler here that just says, accept all the ones named loss with an element quota of 9, he could instead say, accept all elements or all ones named loss with a privacy budget of 0.5 epsilon or something like this, right? Which is a much stricter constraint on the amount of private information that could be allowed to leak. And in particular, things like loss variables and stuff like that, I think are very, very efficient in terms of private, like they don't really leak very, very much information because they're so processed, especially when it's pushed through like squishing nonlinearities and this kind of stuff. Yeah, so lots of features to come to try to make that sort of more robust. But I think, the 80-20 principle here really does apply. Like I think the big jump in ability for the whole data science community is just simple remote execution and simple permissions. These more advanced features will be fantastic, but I think there's a whole lot of exciting work that can be done just with the features that are already included in the package.
So another question is there a way to get around the verbose setup, or is that the nature of the beast? So it seems like you need 2 data individuals, these on one side, maybe a general admin on the other.
Matt, do you want to answer that one? Do you want me to take that one?
Yeah, go for it.
Right now, this is supposed to be a lightweight tool, right? And the idea is that this is supposed to allow for 2 people to do some arbitrary data experimentation, maybe do some data cleaning, this kind of stuff, stuff that's like highly interactive in this setting. over the next several months, you're going to see PyGrid and OpenGrid evolve with features that try to make it so that basically Matt does not have to be around when people are doing data science on his data, right? So in the same way that he added a handler manually here, that he could add categories of handlers for sort of data scientists at large. And like he could walk away and let someone just do data science, and they could provision their own compute and like all this kind of stuff. And for it to be a lot more automated in that sense. And you're going to see interfaces on the data scientist side make it easier and easier to actually search for sort of search across networks of these automatically hosted nodes, looking for data that's interesting to you, right? So we're going to see a lot more automation, both on the how do I make it easier for me to just sort of host my data in a private data network and go away and have lunch, or fall asleep or come back a week later or whatever, right? And then if there's if you assume there's a whole network of people who have loaded their data into a node like this on the network, how do I, as a data scientist, then actually just do discovery and like go out and find data on the network and like search for it and like provision some compute and do some data science and train some models in a way where it doesn't require either person to be online at the same time, or even really know each other. I think that's the goal that we want to get to. So I would expect over the next 6 months or so to start seeing this automation really start coming out. We're working on a pilot with University of California, San Francisco, which is currently ongoing, and I believe it's expected to complete in like Q1 of next year. Sort of deploying this in a real world environment, which we're super excited about. And then these features will be, I think, making its way into the code base between now and then, and of course continuing throughout the rest of the year. But yeah, great question.
So we had a lot of really awesome questions, but we're going to do the last one. And then I encourage you to join OpenMined on Slack. So that's also in the link tree. So just go ahead, join us, ask all your questions. And it's a great community. So welcome to join. But the last question is, how do you verify that the request is actually for getting average?
Yeah, so great question. So in this case, this goes back to the answer I gave before. In this case, we sort of assume that these two people are working together. They're both on a Zoom call together. They're both sharing their screens. And like Matt, for example, has like these little statistics that show when messages are coming through and how many objects there are. And it's like, there's just like a general sense of context for what's going on. Matt also has the ability to actually look at the tensor that he's about to release before sending it. So, if it turns out someone's asking for a tensor that's, 1,000 by 1,000 parameters when it's supposed they're asking for a mean. Like there are some lightweight ways of detecting this, but in the future, the real gold standard is automatic differential privacy budgeting. Because like at the end of the day, that's the whole science around being able to put a maximum degree of probability that information is leaking from your computation, especially when you're doing some very sophisticated data science techniques like training machine learning models and this kind of stuff, where there's no way that someone's gonna be able in their head be like, well, you did 47 matrix multiplies and 27 matrix transpositions, and then you slice. It's like people aren't gonna be able to keep track of that in their head, and they really gonna need automated tools to do that in a hardcore way. But I think, again, the 80-20 principle rule applies. Just the fact that Matt doesn't have to send me the copy in order for me to work with it is already a tremendous amount of value. It's not that it's totally impossible to try to socially engineer a situation where data could be outright stolen. But when you think about all the different data science, it's not even able to be done just because data has to stay in a geographic, it can't leave the country, or it can't leave the enterprise server, or it can't leave, and so there's like a lot of data science that simply just doesn't get done because of hardcore geographic limits, even between people who have relatively high degrees of trust with each other. Duet is a really, really powerful tool already, and it will increasingly become powerful to these more open-ended and sort of potentially adversarial scenarios as more robust features like automatic differential privacy tracking make their way into the code base.
Awesome. So I'm just going to wrap it up with letting you just tell a little bit about the upcoming private AI series. And I'm going to share a link to that as well. It's also in the link tree. So you have all the links you need, and one link to rule them all. Remember that. Just use that link. But Andrew, Matt, would you like to go ahead and tell us a little bit more about that?
Matt, please.
Yeah. So this is something I'm very excited about. So we are developing a totally new online education platform to host a series of courses about privacy preserving machine learning. So this is, we're calling it the Private AI series, and it is a series of 4 courses. So the first one is for like non-technical people, just anybody who's interested in privacy and security. And it kind of introduces you to what the issues are around privacy and how you can actually like use privacy for new innovations and opportunities. And it's really exciting. And yeah, that is being released on January 2nd. So in just a couple of weeks. We're very excited for this. Yeah. And then the second course is about foundations of kind of privacy technology. So we're teaching students how to do a lot of these fundamental algorithms like homomorphic encryption, secure multi-party computation, teaching students how to do these like from the ground up, from scratch, using like NumPy, and then showing them how to do it in PySyft, like kind of the more modern tools, right? And what's really exciting about this is like at the end of this course, we will be having students actually do their own duet sessions like this. So you as a student will be actually working as the data scientist and the data owner and facilitating this communication between each other. So it's gonna be really exciting. And then the third and fourth courses are going to be how you actually do this stuff in production. Like if you're working at some enterprise, how do you actually set up your own data nodes? How do you work with other people's data nodes? And then also how do you build like mobile applications using federated learning, right? So how do you actually take all the stuff that you're learning and put it into production, into use, right? So this is all very exciting. I am super pumped. And yeah, so this the first course is released on January 2nd. And if you would like to sign up, we actually have a limited number of seats. So we, thanks to our partnership with Facebook and Facebook AI and PyTorch, we are actually able to provide support through project reviews and technical mentors. And so our mentors will be able to help you as you're going through the courses. And yeah, but we only have a certain number of seats available for the support. So if you would like to be a part of that, be a part of the first class of these courses, you should sign up today. We are starting in 2 weeks.
Woohoo!
Super excited, hey? So I'll share the links and join us on Slack if you have any other questions. Matt is there, Andrew is there, I will be there as well to answer your questions, help you out, and anything you would need. So really awesome that you could join us today, and this was fun, Andrew, Matt. So let's do this again. But join the courses and wish all of you an amazing Saturday as well. So thank you. Bye, everyone.
Bye.
Bye.